All right, guys, you're welcome to the 39th question, still on the challenge, and we are still solving problems on differentiation. Here is another exciting problem. You want to see how we're going to go about the solution, and you already know we do this stuff one step at a time. So if you still have problems with previous questions, you don't have to keep it to yourself. Put it down in the comment section, and you're going to see the video solving those problems in the next video series. So guys, what I'm trying to say is that we are very close to our community and we are very interested in how we can help you get better in math. So do not hesitate to reach out to us if you have any challenging question whatsoever. So guys, how do we go about solving this problem one step at a time? Now, what I want you to take note here is you're going to apply a different rule in this particular problem. And that rule is called quotient rule. It's called quotient rule, and that is what I want you to get used to from this very video. So what does it say? It said if you use a function of a and v is a function of x, maybe you have what sorry please, if y is expressed as u upon v such that u is a function of x and v is a function of x. What I mean by function of x, that means you can differentiate u with respect to x and v with respect to x. That is what I mean. So if you have y to be in this kind of expression and you want to find the derivative of y with respect to x, all you need to do is to just utilize the chain rule, which says you just have to hold the v, differentiate the u, you get it, then subtract minus, now you hold the u, and you differentiate the v, and finally you divide every stuff by v to the square, like v squared. So this is pretty much how you go about it, and it's quite easy. Remember, you start with the v, guys. Do not forget this stuff. Do not confuse this with the product rule. No, remember, product rule is different. It's addition. This is chain rule. You want to start with the denominator, which is v, hold the v, differentiate the u, minus, hold the u, differentiate the v, and all upon v squared. So let us see how we can apply this concept in this particular problem here. So from this problem, this stuff here is just like my u, and this stuff here just like my v. You remember? So if I really want to differentiate this function, the y dx, I'll need to hold my v, which is x plus 3, I'll differentiate my u, x plus 2. If I differentiate x, I get 1. If I differentiate 2, I get 0. So I end up having 1, differentiating u. Then minus, take note, is minus, not plus. Then the next thing you want to hold your u, which is x plus 2. And you want to differentiate your v, which is x plus 3. And that will become, if you differentiate x, you get 1. If you differentiate 3, you get 0. So that is just 1. And all upon the v squared. What is the v? X plus 3. Then you want to put a square right on top of it. So that is simply how to differentiate rational expressions like this, utilizing the chain rule. I hope it's really straightforward. The next thing you want to do is to just clean up the expression. Of course, you know, anything, this 1 multiplies all this stuff is the same as x plus 3, and this stuff multiplies the same as x plus 2, and that is all upon x plus 3 all squared. Then remove the bracket. Definitely you have to remove the bracket, so the negative affect everybody here, and that's going to become x plus 3 minus x minus 2 all over x plus 3 all squared. Of course, you see the s can cancel out the x. S minus x is 0, and 3 minus 2 is 1. So that becomes 1 over x plus 3 all squared. That is the final answer, and that is my dy dx. So guys, how easy is this stuff? Let me know in the comment section, and if you still have doubts, please put it down in the comment section. We are very much interested in how we can help you get better in math. So do not hesitate to reach out to us with any math problem you're having whatsoever. Okay, so thank you very much for watching, and do not forget to share this video to other learners, and that is one way to appreciate us. So thank you guys, and God bless you as you prepare for the test. Bye.